Quideo number 5 by the Jackson Gutshall. Alright? We're just going to start out here with a basic question. This basic question is really simple, if you're smart like me. Here are estimates of the daily intakes of calcium for 38 women between the ages of 18 and 24 years who participated in a study of women's bone health. And here are the estimates, right here, okay? So we're going to come in, start on A. It's pretty simple. It asks you to make an Instagram. I could do that in my sleep. Alright, so here's the categories of the Instagram. Goes up to 12 because that's the maximum number of each interval on the histogram. So that's A, pretty simple. Go up to B. You're going to have to calculate the mean, standard deviation, and the standard error. The mean is going to be 926 of the data. Got that by a simple data entry into my calculator. Go. So the standard deviation is going to be 427, and the standard error is going to be 69.3. So now we move down to C, which is asking to find a 95% confidence interval. And to find that, you're going to put 926, which is your mean, plus or minus 2.042 times 64.3. And you're going to get the answers as 784.5 and 1067.5 because it's plus or minus. Come down to D, and you're going to calculate it without an outlier. Your mean is going to be 156.2, standard deviation of 306.7, standard error of 51.1. Your degree of freedom is going to be 30, and you're going to do 856.2 plus or minus that same 2.042 times 51.1, and that's going to equal 751.9 or 960.5. So that's how the numbers are different with or without an outlier. Okay, so now we're up on the advanced question, and it's asking if you play 2 games against the same opponent, and it explains the probability if you win and lose. So A on the advanced question is asking, what are the 2 games independent? And no, they're not independent, because as the question clearly explains, that the probability of winning the first game is affects the probability of winning the second game. Move down to B, and it's what's the probability you win both games. You'll take the probability that you or 0.67 times 0.7, you're going to get equals 0.42, and you get that by getting 0.6 from there and 0.7 from there, the opposites of those numbers. For C, probability you win both games, it's going to be 0.4 times 0.2. You just use those 2 numbers, and you're going to get an 8% chance. So then it asks you to come down and let random variable x be the number of games you win and construct the probability model. So here's x and here's the probability. The probability you win 0 games is 0.42 as stated in B. Probability you win 2 games is 0.08 as stated in C. Probability you win 1 game is 0.5. Come down to E, and the expected value of this is going to be 0.66, and the standard deviation is going to be 0.62. Yeah. So now on the last question, which is the AP question, because we are AP students here, and the overall question is asking if there's a significant difference in the mean amount of E. coli bacteria detected by the 2 methods for this type of beef. And you're going to have to provide evidence for your supports. So that means you're going to do phantoms. So the parameter in phantoms, which is the P, is the difference in mean amount of E. coli bacteria detected by 2 methods for this type of beef. Come down to H, your HO is going to be mu equals 0. The HA is mu is not equal to 0. Your A in phantoms, which is assumptions, is the SRS is already given to you. You're going to have to assume independence, and you're going to have to guess that the graph is approximately normal based on the fact that it's 0.05. Come down to N, which is name of test, and it's match paired t-test. So you're going to get the test equals the mean of D over standard deviation divided by square root of the number of D. And so the numbers you plug in are 0.29 minus 0 over 3.6589 equals 0.0973, and you'll get a degree of freedom of 20 minus 1, which is 19. So the O you come down to, you make your observation that P equals 0.9377, or P is between 0.2 and 0.15. You make a decision, and you're going to fail to reject the HO, and you're going to fail to reject the HO, as I state in my summary, because there's not enough statistical evidence to prove that the hypothesis would be wrong in this situation. Thank you.